Hi, hello, good morning, one and all. Today we are going to discuss about Wheatstone Bridge principle. At the same time, derivation for Wheatstone Bridge condition. Right. Wheatstone Bridge. Wheatstone Bridge is used to measure or calculate or determine unknown resistance of given wire. So right. So now here, Wheatstone Bridge has four junctions. Four junctions. So it is works in between principles, apply two principles, Kirchhoff's laws. So right now, so for example, Wheatstone bridge diagram. These are four junctions. Four junctions. It is A junction, B junction, C junction, D junction. So observe here, these two junctions, middle junctions, are connected to galvanometer. So, remaining two junctions are connected to cell or battery. So, it is positive, negative. Right. So, observe here, its resistance is R1 only considered, its resistance is R2 only considered, its resistance is R3, it is R4 only considered. So, what current is passes? From positive terminal, current is passes. So it is total current is I, but it is a junction. From junction, so it can be split into two currents. So that is, some current is I1 only considered, remaining current is considered as I2. Clear? Right. So this side, A to B side totally I1 current only passes. Next again junction came. According to junction, so some of the enter into the junction, some of the current enter into the junction equal to leaving from the junction. Some current is passing like this, some current is passing like this. Here it is galvanometer. So galvanometer, the current which is passes through the galvanometer, that current is said to be galvanometer current I suffix G. So next remaining current is I3 only consider. Next. So now here I2 current is passes this side, that is I2. So again junction came. So towards the junction, this side IG current is passes. So like this way. Next these two currents are passing towards the junction. Then combined to pass like this way. That is I4 only consider. This side is I4. This side is I3. So next junction came. These two currents are passes towards the junction C. Then combined current is I only consider. So it is I. Right. Right. This is Wheatstone bridge. Right. Then, so now we'll write. So what terms are there? That only first we should write. Where let R1, R2, R3, R4 are resistances. Next, I1, I2, I3, I4 current through the junction or currents. Next, capital G is galvanometer resistance. Galvanometer resistance. Okay, right. So I means what? So I means total current. Right. These are the assuming terms. Right. Now apply Kirchhoff's law for this junction. Two junctions are the next loops. So apply Kirchhoff laws. apply Kirchhoff's laws. First we should apply first law. First law means what? Junction law. So junction law is applied for only what junctions we want, that only we should apply, remaining don't want for question answer. So otherwise we want total detailed information means first apply A junction, B junction, C junction, D junction. But we want only B and D junctions only for question answer purpose. So first law is apply. First law is apply for junction A. Detailed information, junction A. Junction A only you should observe here. Sum of current enter into the junction is equal to sum of the current leaving from the junction. That is meaning, that means definition. According to definition, sum of current enter into the junction, arrow mark only you should observe. I current only entering into the junction A. So that's why I. Remaining two currents are there, that is leaving from the junction, move away from the junction, these two are. That's why I1 plus I2. Are you clear? Right. Next at junction B. Junction B only observe here. What current is entering? Arrow marks only you observe. This arrow mark towards the junction, I1 current. Outside from the junction. So away from the junction, these two arrow mark, this is towards the junction. That's why, so I1 is equal to I3 and Ig are leaving. I3 plus Ig. Understood? Right. Next at C junction. At C junction is observe here C. Entering towards the junction. Towards the junction is, this is arrow mark is towards the junction. This arrow mark is towards the junction. So I3, I4. So I3 plus I4 are towards the junction is equal to leaving junction is I current only. So that's why it is. Next at junction D. At junction D. So at junction D only observe here. What current is entering? This current is entering. This current is entering. These two currents are entering. So that's why I2 plus Ig is equal to leaving current is this one. So that's why I4. So this junction D and junction B only we want to calculation for balancing condition. Understood my all equations? Arrow marks only very important. How much current is entering equal to same amount of how much current is leaving from the junction. That is this all equations. First law is over. Next, this is equation number 1. This is equation number 2 only consider. Next, apply second law. So apply second law. Apply second law or apply voltage law. Revise that Kirchhoff laws, then you can easily understand. So voltage law means what? Current into resistance. It is purely closed circuit related. Closed circuit or closed loop. Closed loop means what? Here two loops are present. So it is one of the loop. A, B, D, A. A, B, D, A one loop and B, C, D, B is another loop. Are you clear? So these two loops we can apply voltage law. So now, what is voltage law? Algebraic sum of potential difference across any closed loop is 0. So that is rule. Right, according to that rule, observe here, first loop, what loop? A, B, D, A. So A to B, B to D, D to A. A to B, B to D, D to A only we want to calculate. So this one. So path is very important. So here. So now, A to B, A to B. Observe here, two conditions are there. What condition? When current is passing through the resistor, then it can be decreases. That's why minus. So minus I1 R1. Clear? Direction of loop, that means path direction and current direction. Both are in same direction. That's why minus. Next, B to D. A to B over. B to D. B to D. So it is also resistance. Galvanometer has certain resistance. That resistance is G, capital G. That's why what current is passes Ig. Loop direction is downwards. Current direction is downwards. That's why minus Ig current in galvanometer resistance is capital G. Ig. Right. Next. D to A. D to A. D to A. D to A, can I clearly observe? Loop direction is D to A, but current direction is A to D. So that's why it is what? Opposite. Purely opposite, that is plus what current? I2 current into resistance is R2 is equal to 0. Are you clear? Understood? Right. Next loop, second loop, B to C, C to D, D to B. B to C, C to D, D to B. Right. Can easily observe Nana here. Same direction, B to C, B to C, and the current direction same. So that's why minus I3 R3. C to D, but current direction is opposite. So that's why plus I4 R4. Next, D to B, D to B, direction of current downwards, loop direction is upwards. Loop direction is upwards. So that is what? Positive. So plus Ig G equal to G. Are you clear? Right. This is 2. It is equation number 3. It is equation number 4 only. Now, from condition, balancing condition of resistor. Balancing condition. Balancing condition of Wheatstone bridge means Ig equal to 0. Why Ig equal to 0? The current through the galvanometer is 0. That is called as balancing condition. Why it is current is not passes through galvanometer means the potential difference between these two junctions is 0. Potential difference is not present. So one thing you listen, any wire can conduct the current means, so should be have potential difference. So that's why current can be passes. But here B and D has same potential, so that's why difference is 0. That's why galvanometer current is 0. That's very important point. Balancing condition. Balancing condition of Wheatstone bridge is Ig equal to 0. Now this condition is applied for equation 1, 2, 3, 4. So equation 1 becomes 2. I is equal to 0, substitute here. Equation I is equal to 0 means what? I1 is equal to I3. Same. Second equation what will come? I2 equal to I4. I2. Second equation is I2 is equal to I4. Next, third equation what happens? Third equation, Ig value 0. 0 into capital G. 0 into anything? 0. So minus IR1 plus I2 R2. Minus IR1 plus I2 R2 equal to 0. So I1 minus I1 R1 is equal plus I2 R2 equal to 0. So now here minus is there, move that side, plus. Otherwise this one move this side means minus. Minus get cancelled. So finally I1 R1 is equal to I2 R2. So this is equation number 5 only consider. Next, fourth equation what happened? When Ig equal to 0, substitute here. Ig 0. 0 and anything? 0. So remaining what? Minus I3R3 plus I4R4 equal to 0. Then what happens? Minus term plus term is there. Move that term means plus will come. So remaining what? I3R3 is equal to I4R4. So this is the equation number 6. Understood, Nana? Understood? Only this one only substitute in all equations. So Ig value equal to 0 substitute in this equation, and here and here. So remaining equations came. Understood? Right. Finally 5 by 6. 5 by 6 only consider. 5 divided by 6. So I1 R1 equal to I2 R2 divided by 6th one I3 R2, sorry R3, it is what? I4 R4. So already we know that here I1 equal to I3, I2 equal to I4. The two equations values can be substituted here. I1 I3 are I1 equal to I3, I2 equal to I4 from that equations. What happens? I1 equal to I3 means these two are cancelled now. I2 equal to I4 means these two are cancelled now. So R1 by R3 is equal to R2 by R4. So this is balancing condition. So otherwise it is also written as cross multiplication. R1 by R2 is equal to, so R1, R2 move this side, R3 move this side. So R3 by R4. These are Wheatstone bridge principle or Wheatstone bridge condition. So this is R1 by R2 equal to R3 by R4. Clear? So cross multiply R1 R4 equal to R2 R3. Otherwise R1 R4 equal to R2 R3. Both the equations have same result. So this is the balancing condition for Wheatstone bridge. I hope you understood. It is very important question for PU IPE. So clearly read. If you have any doubt, comment on comment section. I will give clarification. Okay, right. Thank you.